Uranus, the seventh planet from our Sun, is a mysterious giant. It is an ice giant, composed primarily of icy materials swirling around a small rocky core. Uranus is unique for its dramatic tilt, lying almost sideways. This unusual orientation is thought to be the result of a cataclysmic collision long ago. This event may have also shaped its complex system of rings and moons. Uranus offers a glimpse into a planetary system vastly different from our own. Uranus possesses a captivating family of 27 known moons. Each moon holds secrets waiting to be unlocked. These moons are not like our own. They are not barren, cratered landscapes. Instead, they show signs of geological activity, suggesting dynamic internal processes that we are only beginning to comprehend. Among these moons are 5 major ones: Miranda, Ariel, Umbriel, Titania, and Oberon. These were the first to be discovered, each named after characters from the works of William Shakespeare and Alexander Pope. Their sizes and compositions vary, reflecting the diversity of materials present during the early formation of the Uranian system. The moons of Uranus are more than just celestial companions. They are time capsules. They hold clues to the early solar system and the processes that governed its evolution. Studying these moons allows us to peer back in time and understand the conditions under which these icy worlds formed billions of years ago. In 2003, a faint glimmer in the depths of space heralded a new discovery. Images from the Hubble Space Telescope revealed a tiny, previously unknown moon orbiting Uranus. This new member of the Uranian system, far smaller than its larger siblings, was named Mab. Mab, named after the mischievous fairy from English folklore, is a fitting moniker for this small but intriguing moon. Mab's discovery marked an exciting moment in planetary science. It underscored the incredible capabilities of our telescopes. We could now detect even the smallest, faintest objects lurking in the distant reaches of our solar system. This discovery also opened up new avenues of research. Mab's small size and faintness make it a challenging object to study. However, its very existence sparks curiosity. What is its composition? What is its history? Could it be related to Uranus's intricate ring system? These questions drive scientists to explore further, pushing the boundaries of our understanding of planetary systems. The discovery of Mab was not a deliberate hunt, it was a serendipitous find. In August 2003, a team of astronomers led by Mark R. Showalter and Jack J. Lissauer were using the Hubble Space Telescope for a different purpose. They were studying the faint rings of Uranus, those ethereal bands of dust and ice that encircle the planet. As they meticulously analyzed the images, they noticed something peculiar. A tiny dot, barely perceptible against the blackness of space, appeared and reappeared in different images. This was no stray star or distant galaxy. It was an object moving in sync with Uranus, a clear indication of a moon. The astronomers had stumbled upon a treasure hidden in plain sight. This tiny speck, lost in the vastness of space, would soon capture the attention of the scientific community. Its discovery was a testament to the power of human ingenuity. It also highlighted the importance of careful observation in unlocking the secrets of the cosmos. The discovery of Mab was made possible by the Hubble Space Telescope. Launched in 1990, Hubble orbits above Earth's atmosphere. It captures exceptionally sharp images, seeing objects billions of light-years away, detecting faint objects invisible to ground-based telescopes. Thanks to its sensitive instruments, capturing ultraviolet, visible, and infrared light. Hubble's advanced camera for surveys was crucial, surveying large areas in high resolution, detecting faint, distant objects. Hubble's images are data points. Each pixel contains valuable information, analyzed to determine size, brightness, and motion, confirming the tiny dot was a moon orbiting Uranus. Once the discovery was confirmed, the next step was to learn more about this new moon. The faintness of Mab made this task challenging. Astronomers had to rely on indirect methods to determine its characteristics. They carefully studied its motion. This allowed them to estimate its size and mass. Based on these observations, scientists determined that Mab is a very small moon. Its diameter is estimated to be only about 24 kilometers or 15 miles. This makes it one of the smallest moons in the Uranian system, a mere speck compared to the larger moons like Titania and Oberon. Despite its diminutive size, Mab's discovery was significant. It expanded our understanding of the Uranian system. It also provided further evidence of the complex processes that shaped our solar system. Mab, a small moon, orbits close to Uranus's Mu ring. Discovered in 1986, this faint ring is shepherded by Mab and Cupid. Their gravitational influence keeps the ring particles confined. Mab's origin remains a mystery, possibly a fragment of a larger moon or formed from ring particles. Mab, despite its recent discovery, has already revealed some of its secrets. Scientists, using observations from Hubble and ground-based telescopes, have pieced together a preliminary portrait of this tiny moon. It is a world of extremes. It is a place where the sun appears as a distant cold star, and the icy grip of space reigns supreme. Mab is estimated to be a mere 24 kilometers, or 15 miles, in diameter. To put that into perspective, if you could somehow shrink Earth down to the size of a basketball, Mab would be about the size of a sesame seed. This makes it one of the smallest moons in the Uranian system and a true denizen of the cosmic micro-world. Despite its diminutive stature, Mab is a celestial object in its own right. It orbits Uranus, subject to the gravitational pull of the ice giant. Its existence, however small and seemingly insignificant, adds to the tapestry of our solar system's complexity. Mab orbits Uranus at 97,000 kilometers, completing one orbit every 22 hours. Imagine traveling at 24,000 kilometers per hour. Uranus's gravity keeps Mab in a celestial dance. Mab's orbit is nearly circular, with a slight inclination. Unlike some moons, Mab's orbit is not tidally locked. It rotates, experiencing both sunlight and Uranian night. While we have gleaned some information about Mab's size and orbit, its surface remains shrouded in mystery. Its small size and distance from Earth make it extremely challenging to observe directly. The best images we have, captured by the Hubble Space Telescope, show Mab as nothing more than a faint dot of light. However, scientists can make educated guesses about its surface based on what we know about other objects in the outer solar system. Mab is likely a cold, dark world, its surface covered in a mixture of water ice, rock, and perhaps other frozen volatiles like methane and ammonia. The lack of a substantial atmosphere means that Mab's surface is constantly bombarded by micrometeoroids and cosmic rays, sculpting and altering its features over eons. The surface of Mab is likely a tapestry of craters, ridges, and perhaps even ancient fault lines, evidence of a long and geologically active history. However, without closer observation, these details remain hidden from our view, fueling our curiosity and inspiring future missions to explore this distant world. Although Mab appears as a tiny, insignificant speck in the vastness of space, it likely harbors evidence of a much more dramatic past. Scientists believe that the Uranian system, like many planetary systems, experienced a turbulent and chaotic early history. Collisions between planetesimals, the building blocks of planets, were common, and these events left their mark on the system's moons. Mab's small size and irregular shape suggest that it could be a fragment of a larger moon that was shattered in a collision long ago. This theory is supported by the presence of other small moons in the Uranian system, some of which share similar orbital characteristics with Mab. These collisions, while destructive, also played a crucial role in shaping the Uranian system as we know it today. They likely contributed to the formation of Uranus's rings and the diverse collection of moons that orbit the ice giant. Mab, despite its diminutive size, is a key player in unraveling the mysteries of the Uranian system. Its very existence provides clues about the chaotic early days of our solar system. Scientists believe that the outer solar system, unlike the relatively calm inner region, was once a much more turbulent place. Giant planets like Uranus roamed more freely, their immense gravity disrupting the orbits of smaller objects. This gravitational interplay led to a cosmic billiards game, with planetesimals, comets, and even nascent moons colliding and scattering. Mab, with its small size and proximity to Uranus's rings, is likely a relic of these ancient collisions. Its irregular shape and the presence of other small moons in similar orbits suggest a violent past, where larger bodies were shattered into fragments. By studying Mab and its fellow travelers, scientists hope to learn more about the conditions that prevailed in the early solar system. Understanding the dynamics of these early collisions can shed light on the formation of planetary systems, including our own. Mab holds a particularly intriguing position within the Uranian system. It orbits within the Mu ring, one of the planet's many faint rings. This close relationship between a moon and a ring is not unique to Mab, but it offers scientists a valuable opportunity to study the complex gravitational interactions that shape planetary systems. The Mu ring, like many planetary rings, is composed of countless tiny particles of ice and dust, each one orbiting Uranus like a miniature moon. These particles are constantly colliding and interacting, their movements influenced by the gravitational pull of Uranus and its moons. Mab, with its small but significant gravitational field, acts as a shepherd to the Mu ring. Its gravity helps to confine the ring particles, preventing them from spreading out and dissipating into space. This shepherding effect is crucial for maintaining the structure and longevity of the ring system. Mab is not alone in its shepherding role. It shares this responsibility with another small moon, Cupid, which orbits just inward from Mab. Together, these two tiny moons act as celestial border collies, keeping the Mu ring in check. This delicate gravitational dance between the shepherd moons and the ring particles is a fascinating example of celestial mechanics. The moon's gravity creates waves and ripples within the ring, influencing the distribution and motion of the particles. Scientists can study these waves and ripples to learn more about the mass and density of the shepherd moons, as well as the composition and structure of the ring itself. The Mu ring, influenced by Mab and Cupid, becomes a natural laboratory for studying the fundamental forces that govern the universe. The study of Mab and its interactions with the Mu ring can also provide insights into the formation of the Uranian system as a whole. The composition of the ring particles, their size distribution, and the way they are shepherded by the moons can offer clues about the processes that led to the system's formation billions of years ago. One theory suggests that Uranus's rings, including the Mu ring, are the remnants of a moon or moons that were shattered in a catastrophic collision long ago. The shattered fragments, unable to coalesce back into a moon due to the gravitational influence of Uranus, instead spread out into a ring system. By studying the composition of Mab and comparing it to the composition of the Mu ring particles, scientists hope to determine if they share a common origin. Such a finding would support the idea that the ring system is the result of a moon's demise. Mab, despite its small size and distance from Earth, offers a wealth of information about the formation, evolution, and dynamics of planetary systems. Its study has the potential to unlock secrets about the chaotic early days of the solar system, the complex interplay between moons and rings, and the fundamental forces that govern the universe. Future missions to the Uranian system, equipped with more advanced instruments, could provide even greater insights into Mab's composition, surface features, and internal structure. These missions could also study the Mu ring in greater detail, mapping its density and composition, and tracking the movements of its shepherd moons with greater precision. Each new discovery about Mab and its surroundings brings us closer to understanding the intricate workings of planetary systems, both within our solar system and beyond. The continued exploration of these distant worlds is crucial for unraveling the mysteries of our cosmic origins and for inspiring future generations to reach for the stars. Mab's diminutive size and its location within the Mu ring present a captivating puzzle for astronomers. Did Mab form alongside the Mu ring? Or is it a fragment from a catastrophic collision? The answer reveals the history of the Uranian system. Mab's existence within the Mu ring also highlights the delicate gravitational interplay between the Moon and the ring particles. The Moon's gravity, while weak compared to that of Uranus, is still strong enough to influence the motion of the ring particles, shaping their distribution and influencing their long-term evolution. This delicate balance between gravitational forces raises questions about the stability of Mab's orbit. Is the Moon's orbit slowly decaying, destined to spiral inwards towards Uranus over millions of years? Or could interactions with the ring particles actually be pushing Mab outwards, extending its lifespan within this celestial dance? Answering these questions requires detailed observations of Mab's motion over long periods, tracking its position with exquisite precision to detect even the slightest deviations from its predicted path. Such observations could reveal the subtle tug of the ring particles on Mab, providing insights into the long-term fate of this tiny moon. Unraveling the mysteries of Mab's origin and fate requires more than just observing its motion. Scientists are eager to learn more about the Moon's composition, its surface features, and its internal structure. Such information could provide crucial clues about its formation and its relationship to the Mu ring. One promising avenue for future exploration is a dedicated mission to the Uranian system, equipped with instruments capable of analyzing the composition of Mab's surface remotely. By studying the light reflected from the Moon, scientists could identify the presence of specific minerals and ices, providing insights into the conditions under which Mab formed. Another tantalizing possibility is a daring mission to land a probe on Mab's surface. Such a mission would allow scientists to study the Moon's composition in detail, analyzing its surface materials and searching for signs of its past. A lander could also deploy instruments to study Mab's internal structure, searching for evidence of a differentiated interior or a subsurface ocean. While Mab may seem like a small and insignificant object in the grand scheme of the cosmos, its study has far-reaching implications for our understanding of planetary systems throughout the universe. Mab, with its unique characteristics and its enigmatic relationship with the Mu ring, serves as a cosmic mirror, reflecting back at us fundamental questions about the formation, evolution, and ultimate fate of planetary systems. As we continue to explore Mab and other small bodies in the outer solar system, we are constantly refining our understanding of the processes that govern these distant worlds. Each new discovery brings us closer to unraveling the mysteries of our cosmic origins and to appreciating the incredible diversity and complexity of the universe we inhabit. As we gaze towards Uranus and its enigmatic moon Mab, we are filled with a sense of anticipation. The quest to unravel Mab's secrets is far from over. Each new discovery only deepens our fascination with this tiny world, a mere speck orbiting an ice giant in the distant reaches of our solar system. Currently, there are no dedicated missions slated to revisit Uranus and its intriguing system of rings and moons. However, the scientific community recognizes the immense value of exploring this distant realm. Proposals for future missions are actively being discussed and refined, fueled by the tantalizing questions that Mab and its companions pose. These future missions, equipped with advanced technology and driven by insatiable curiosity, hold the key to unlocking Mab's deepest secrets. Imagine spacecraft capable of piercing through the veil of distance, capturing high-resolution images of Mab's surface, analyzing its composition in unprecedented detail, and even landing a probe on its alien terrain. The story of Mab reminds us that exploration is an ongoing journey. It highlights the importance of venturing into the unknown to uncover hidden wonders. Each discovery can reshape our understanding of the universe. Mab's significance extends beyond its size. It challenges us to contemplate the vastness of the cosmos. Imagine countless worlds beyond our own. The study of Mab is a quest for knowledge. It reflects our unyielding desire to explore, to understand our place in the universe. The universe is full of surprises. The greatest discoveries are often unexpected.